welcome to another video. So we're doing Advent of Code, which is a coding competition run every December, and this year we are doing it in SerenityOS, which is a hobby operating system. Not the one I make, another one that's a lot better than mine. And we're going to be using a programming language called jakt, which is experimental, but it just adds to the fun, I reckon. Right, that's not the one, that's just the one we just did. I have got my times mixed up. No, I think I just need to do like a thing. Yeah, there, now we can click on 5. There's some caching issues with Ladybird. So, day number 5. So we can start a new day 5. Let's have a look and see what some input looks like. Right, it might look like this, I guess. Well, we know the output. The output was CMZ, I guess. So part 1 CMZ, and what we can do is look at inputs day 5.input. Yeah, so it's like these move instructions. So I guess these ones. And it does start kind of with that kind of setup. And so I think I need to have that kind of in the background, and I'll also day 5.example. We never actually saved it, so that's why it's complaining. Alright, so let's see what that thing looks like, and then gosh, we're gonna have to like make what it looks like. This is an example of why where I probably could scrape it. In fact, I could like copy paste it from let's do 2 and 3, and yeah, I could copy paste it from the host operating system, but I think this is probably good. So these are all like spaced out and like 3 in between the numbers, 4 maybe. Right. And only 1 there. So yeah, I think the numbers are like just slightly off by 1, and these just have the 1, but some of them might have a bunch. Yeah, cool. We'll call that the input. We can potentially massage it better depending on what it is. But yeah, let's have a read through of what we're doing. So the story so far was we had some elves that were going through the jungle to find some stuff, and eventually they'll like save Christmas by day 25 with the help of these programs. The last thing they did was work out that they had too many people cleaning up their areas, but now it sounds like they're ready to go. So to load up, they have a bunch of crates for their supplies. There's a crane that can move the crates. It's interesting, reading these problems makes me think of like kind of more complex things like dynamic programming to like slot in the like pack a crane like perfectly, pack a box perfectly, but it'll probably be a lot simpler. Right. Right, so Crane rearranges them in a bunch of steps. So we've got steps, and we probably have these steps here. Right, they don't know where the crates are going to end up, but they want to know so they can do it. So they're basically going to work out from the input where it is. So this is how it first looks. So we've got like starting stacks, and then what it looks like, then instructions on how to do it. So I guess this would move 1 from 2 to 1, so it'd move like D across. So it'll move D across, and then 3 from 3 to 1. 3 from 1 to 3. So D and Z would go there, and it reverses. So it's like everyone is a stack. So it has to last in first out. Right. And what do we have to do at the end? Right, we just need to know what's at the top of each stack. Cool. So this one, the input is potentially a bit trickier. Don't want to do that. So what we can do is open up our text file, our source code, just happens to be text, and we need to start working it out. So the first thing we need to do is read the input. So at some point, the input is going to be empty. Read start instructions, I guess. And that can probably so we need to like kind of keep track of when that goes. Initial equals, we can have initial, and then initial equals false, and then like in here, if initial, we are going to be doing some reading stuff, otherwise we're going to not be doing some reading stuff. And in this one here, we probably want to continue afterwards. So I think I'm going to run tests on day 5 and example, because I don't want it to spit out everything. If and else have identical blocks. That's because we just don't do anything. I don't know, print read initial, line, read instructions, and probably do the line if I get my fingers right. I don't often use the mouse as much as this, and fingers get slightly off. Right, so we read initial, read initial, read initial, read initial, and it never prints out read instructions, I guess. That is because we never day 5 dot example. We never actually did the full instructions, so I think we need to always on top of this and move 1 from 2 to 1. And actually move now if I run that again, it should start instructions and it's reading instructions on all of those steps. Cool. So this initial step, we need to kind of know like where things are. I'm gonna input. Yeah, this looks how I thought it would, but I think the font in the other editor was just a bit strange. Yeah, like the numbers all line up and everything looks very stack-like. So we can kind of see a stack is 4 characters, 1, 2, 3 for that, and then a space. Then 1, 2, 3, and then a space, and the last one we just won't have that. So what we could do is 3 characters, then if it has more, and like go up by substring to work out whether something is in there, or like we can actually just look at this position, this position, this position, and if it's not a space, like that is a space, so there's nothing on the stack. And once we kind of parse in the stacks, we want to almost like reverse them, or like I guess when we're adding a new row, because we want this to be at the top. Yeah, so how we would add this would be every line, let's just create a array anyway. So mute stacks, and they are going to be basically going to be an array of, I wonder if we have yeah, I suppose we could just have a stack, and a stack is going to have a data, and that can be an array of strings, and we'll only add to it in a certain order, I guess. And then this can just be an array of stacks. And we don't really know how many there are at the moment. But for every, yeah, like down here, for everything we have a length, and we know that 0, 1, so let's do a comment. Would have 1 and then add 4, I guess. 1, 2, 3, 4. Yeah, so we'll add 4 to 5, then we'll have 9, 13. So those are the bytes we're reading. And yeah, I guess what we can do is we can have a loop equals 1, and I don't actually know the syntax for this, but we'll figure it out. I is less than 1.length, and I can plus equal 4. And then we can kind of work out what index into the stacks it should be. So let idx equal, and there will be I minus 1 divided by 4. Divided by 4. And that would all be 2. Bang. And what we can do is maybe see what that looks like before we do anything with it. So if we do this, it doesn't like that. Right, this, yeah, this eye is probably not good. But we also need to make that empty. Yeah, so what we could do is source jakt and maybe get grep in samples for grep for space, maybe space for space, and we can look in samples. And yeah, I kind of want to see whether there's anything that this can go not always on top. I want to see if there's a way to like skip it by 2 if we're going to do like a countdown, I guess. Looks like we can go from 0 to a certain amount, but we can't like skip by a bunch. What about just everything? These like MDs. We need to only have jakt files. And this is in runtime, so that is kind of good. No, that I was thinking that might be it, but not. I think we'll have to just do it a slightly different way. And yep, let's go to here. So we kind of need to track the index equals in 0. Though I wonder if that is an option. No, I didn't like that. Oh, but I didn't like the, yeah. I didn't like how we just weren't doing that. I mean, it still doesn't, but that's alright because it's doing other stuff. Range different types, so do we have like a while loop that we can just get this going? Grep. We want that one as samples, and we want to change 4 and replace it with while. And save that. Yep. Queue. Right, so we can do a while. So I think that's what we'll do. So we'll have meet I equals 1, and while I is less than line.length, do some stuff, and one of the things you'll do is I plus equals 4. And then we can probably get that and Right, so it doesn't like this. Yeah, so I guess this I needs to be, I guess we could call it a U size. It's going to be a U size. Right, still not there, but that's a bit better. I guess we could do something like that, because the trimming to an int will kind of do it, but it's not liking dividing. So I guess, can this be U64 instead, and would you like that? No. What if we do as bang I64 in there? No method there, long value. How do we just get I divided by 4? Alright, that built. Well, it is building. Yeah, I think that's good. So for that one we could read 2 indexes, and it's because we're reading that one, then that one, and then we can read 2 again, N and C, and then we read 3, which is Z, M, P, and then we read 3 again, which is the numbers, which I guess is another reason we can ignore them if they are numbers. But for now, what we can do is look at maybe what the byte is, and that can be line.byte at and I, which should be theoretical, and no, we don't like that. Yep. I wonder if we can just have that again. Right, so we can do just I4. We're just going to do the 2 in time. I guess we'll strip because it's a right, so now we get whether it's we can see whether it's a space, or later on we can see whether it's a number. So I wonder if we do our grep again, and I think I will actually quit that and export editor equals vi and do that. And instead of looking for while, let's look for inside of that is digit. Right, we potentially will just have to do that ourselves. So I guess we can try that. Function is digit, and we can take a non, and that can be a byte of U8, and we will return than greater than equal to 0 as being U8, and B is less than 9 as being U8, and function is and we'll just make this as well, and this can just return B equals as U8. And then down here we can probably work out where the things are there. So the IDX is the, so I guess we can let B equals 1 by xi, and so this IDX I might rename to stack, I guess, or stack IDX. And here we can, if is space B, we can do some things. And I think we actually want to do if not is space. And I think if is digit of the, we just want to continue. Or potentially, yeah, we just want to break out of this loop because it's just not that interesting. But if we are at that point, what we can do is probably print line stack IDX equals that, and thing, and that can be that, and the thing we can probably print as a character, and we can change that to B. Yes, so yeah, that was actually the one I wanted, but who knows. So if we run this now, choo choo, might hear a train in the background, must be freight time of night. Right, so yeah, we can see the stack index is 1, thing is D, and that's it. And then N and C, Z, M, P, and read initial. So that's pretty cool. So I guess if stack IDX is greater than stacks.length, we need to like grow it. So I think what I want to do is go back to here and look at the runtime and jakt, and like array. Where is like an array type? Built-ins maybe? Yeah, array. Or we could be, yeah, I think array is what we're in. So we've got a shrink, that sounds good because we can potentially add capacity, add size. Yeah, resize, that's what we want. Stacks.resize and stack IDX, I guess. So if the index is 0, we actually want to add 1 to that. So they'll make sure that there is enough stuff in our stacks. And I guess what we could do here, I kind of want to know if it if it like initializes what a stack is. Size for array, and length for some things and size for others, or potentially, yeah, length for string and size for that. Reminds me of, I think Java does that. That's what I learned a long time ago. Right, so couldn't compile one of the later stages. Yeah, so we don't know how to initialize a stack. So I guess there might actually be something in samples and structs. Well, look in it. What do we have? Field default values. No, we kind of want. Let's just have a look at all of them. That one doesn't help us. Right, so it's got a function. You can put functions and stuff, so they're kind of more like we've just gone back. Yeah, we've just gone back. Yeah, what about grep of initializer? I think that's the spelling it has. No, we don't have that keyboard shortcut. We need to instantiate constructor. Right, so we can do like construct. I reckon that. Fin samples apps JSON con. Yeah, I reckon this construct is potentially something. So what if we, in our stack, function construct, and it returns a stack, and it can just return stack with data being empty array. Yeah, and it might need a public, and it probably needs throws. So public and throws, we'll see which one. Yep, so we need throws because we create an array. Doesn't need to be public though, maybe needs to be public. Let's chuck public in there just to check. Nah, we can't do that. For the sake of time, I'll probably not do that, and we'll just like grow it a different way. Maybe by doing that and stack data, and maybe all that can go away. Right, we don't do add? We had an ad, didn't we? Push. That's the one I wanted. So instead of add, we want push. Alright, so that looks good. And while it's emptier than that, it will grow it out. So here we can see stacks is just one stack at this point because we've kind of added one. And we're not like adding anything to the data. So maybe at this point we can go stacks stack idx data, and I guess we can go push, and this can be we can probably just have it as a U8, I guess. And that can just push B. And see what this looks like. Oh, it crashed. Yeah, that just crashed. So it crashed when we were like adding, or we were still trying to get it. I think I want that, because when the index is 0, yeah, because we had the +1 and the resize operation, so we definitely need to grow one past the current index because we're 0 based, and that didn't crash, so that's good. I think it would be better if this was like a char, but then it will probably complain. Yeah. So we don't know char is C char or something. C char. Yeah, I think that's good. And we can as C char. And my hope is that it will like auto fancy print. Oh yeah, we just need to say that U8 is definitely a C char. Cool, that's looking better. Well, it's compiling again. Right, and here we can see first stack has nothing, then it has D, and then we have N and D, and then N and D, then C. So it's like added it below it. So the 0th element will be at the top, I guess. And so at the end here we can see we have go to this one. So we have NZ, so N is the top, and then DCM, and then P finally, and we skip that. So I think that is reading everything. We probably don't need that, and we probably don't need that, and we probably don't need that and that. And I guess we can move that up there. Maybe at this point we can define stacks equals stacks. Actually no, it might be nicer to just cleaning up some of the input fields. Now we're on to the second part of the input, not the problem, but now we're wanting to read the instructions. So from move 1 from 2 to thing. So at this point, I think we want to grab a split of our string, line.split. And here we can maybe put a comment of get that somewhere in our view. Move in from A to B. So it's going to be what it is. So I won't bother with that. I was just going to show what the cool. So let n equals split. So that's going to be 1.2 int, and we'll do that. Let a equal. I'm sorry, I don't really like the capitals as variable names. I mean, yeah. So that will be 3.2 int, and let b equals split 5.2 int. Right, so now we have our a, b, and what we could probably do is make n mutable, and then yeah, then while n is greater than 0, do like a move operation. So that's going to be stacks, and these arrays are one base, so we need to get, we're moving from, in fact, let's change this from source and dest. And I guess like maybe wrap that round. So I wonder if there's a push, but it's pushing into the end. I kind of want to push to the front. So push, insert, yeah, insert 0. That's what we want. Insert. Oh, we probably need. Yeah. And we want to take that from source -1 dot data dot. We kind of want to remove. So that needs to be that. Oh yeah. Actually, I wonder if we're not in that. Yeah, it has done it. Cool. Alright, we'll that. Where was it? Insert before index and value. We also wanted like a delete pop. Yeah, so if it's that way around, I think we want to go insert 0 there, and here we can just do the push and pop. Cool, and we go back to this guy and run our test. Right, we're going to crash. Yeah, before index we need, we don't need that, but we do need on the insert. Before index, it's going to be that, and is the other one on? No. I feel like I'm missing. Oh yeah, we just need to do that. So while we do that, it's still feeling like it's missing some things. This feels better. Before index and yeah, value is what we need before that. So one feature of jakt is you have to say what the and we will just assume there is something there. It's not the best assumption, but we're kind of assuming that the problem is solvable. And we want to just know the top of everything. Are that like that failed. That failed because I think this source didn't have a thing. But where else do we do a bang? It's definitely optional. Like if we do this, then we should also be doing n minus. And I'm thinking if we comment out that line, we should kind of still work. Oh no, that just magically worked. Oh yeah, because we weren't decreasing n, we were continually trying to pop it off. So we could probably have a look, see here. So after the first one, before the first one, we have Z, N, M, C, D, and P. I'll assume it's just off the screen. Next we had Z, cool, and then we kind of move those two over, so we should have nothing, then MC, then PDNZ, PDNZ, and D. Cool, yeah, I think we have probably enough that we can print the top of the stack. So I think I want to do print like that, and then for stack in stack, print, and we can just print it as is, I guess. Stacks.data peak maybe. everything in one stack. Does it talk about not having any in one stack? It does not. It does not. And then I guess we'll line that. Oh, I didn't like that. Right, so we don't actually have a peak. We don't need to do that because it's already open there. So we have a pop, which I guess is just doing this at. Yep. Stacks.data dot size for this one, and I guess we don't need that, but we do need -1. Yeah, give that go. Oh, is that because this is linked, isn't it? Node size. Oh, we need yeah, and I think it was size. Gosh. Right, doesn't have an app because we secretly just go like that instead. Index used on yeah, cool, that looks good. Might just have the answer. If we do, yeah, that might just be answer. Get ready. Right, cool. So let's run it for the actual input, and what do we have? Click there, Z, W, H, V, F, W, Q, W, W, Z, W, H, V, F, W, Q, W, W. Yep, that sounds good. And that was right. So what I might do is copy that and then outputs day. What are we up to now? 5 dot output, and Control Shift V. Right, mouse is locked up. I wonder if we've got a panic. Might. Yep, we got that same panic. It's interesting that it didn't kind of show me there. Right, we'll run it again and hope that yeah, we just need to run the output again and they'll get what we want. And then we'll need to look at problem 2. Oh gosh, we also need to just do some housekeeping. 16.4. 16.4. We definitely will need this because I'll need to do some secrets. Right, so we'll have that. We'll also have that, and we'll also have that. This can go down there. This can go to adventofcode.com, and this can also also advent of code, that one, build day 5, and we'll just output that to day 5.output, and that is that. And if we have a look at what we've done, so we added some functions, we did a bunch of parsing. I probably could pull the parsing out into a different thing, but that's alright. Day 5 part 1, and we'll quit that, and I'll push that up now, and I think I'll come back to part 2 in a separate video, just because this one has taken a bit longer. Maybe I'll have a quick read first. Alright, what do we have to do? Oh no, it was the wrong crate mover. It's the next model up. Right, so we do 2 at once. That means that the order stays the same. And what will it be if that? Yeah, alright, I'll give this a go. Day 5, jakt. Except let's get you in. Not that node, that node. Yep, come on. Right, so basically at this point here, we almost want like an intermediate spot. Yeah. It's a bit annoying. Because I kind of want both solutions to be able to be run at the same time, just output the same. But this we kind of need to have 2 stacks, I guess. And that can be a stack. We need to add this one. Maybe when we get to this point, we can go stacks 2 equals stacks. Oh no, I think this is too much. Yeah, I'll end it here and come back to part 2 in a different video.